The next line in our code analysis is this one here. So we imported torch audio, and then we're using this torchaudio.load function. And here we're passing a string with the URL of the audio file, the WAV file that we want to load. And this function is returning two data types. One would be a variable called waveform, and another one sample rate. So this is very similar to what we did before using librosa, but now we are using torchaudio.load. So in this case, we are here in a Linux environment. So Google Colab is running on a Linux environment, and we have this definition here of the load. So it loads audio data from file. So note that this function can handle all the codecs that underlying libsocs can handle. However, it is tested on the following formats. So we can load Wavefile with 32-bit floating point, 32-bit signed integer, 24-bit signed integer, 16-bit signed integer, and 8-bit unsigned integer. So we've talked about this before, about the bit depth. So if you're not familiar with binary numbers, if you want to understand what it means to use an 8-bit unsigned integer or a 32-bit signed integer, you can go to our playlist and you can check our DSP theory part when we cover the bit depth and also the binary numbers revision. But it can also handle MP3, FLAC, and other formats. But notice that libsocs does not handle natively. So your installation of Torch Audio has to be linked to libsocs in corresponding codec libraries such as libmed or libmp3, lame, and etc. By default, there will be normalize equals to true. So we scratched the surface of normalization before. We just mentioned that the normalized samples will be in the range of -1 to 1. So if you load, for example, a WAV file that was saved using 16-bit format, for example, so we will have values going from -2 to the power of 15 until 2 to the power of 15, and then it can be normalized. So the maximum value will be mapped to 1 and the minimum value will be mapped to -1, but we'll discuss normalization in future tutorials. But just have in mind that by default this function here will normalize. So this function returns a tensor with float 32, the type, and the shape. It will be here number of channels, and here the time. Torchaudio.load is part of the I/O functionalities, and the I/O functions, they are implemented in Torch Audio backend module. But for the ease of use, there are these functions that are made available on Torch Audio module. So we have this Torch Audio info, Torch Audio load that load file into Torch tensor object, and Torch Audio save. So we are using this Torch Audio load, but it's part of this backend. And this backend module provides implementation for audio file I/O functionalities. And there are currently 4 implementations available using SoxIO, which is the default for Linux or Mac OS, and SoundFile, which is the default on Windows. So as it's mentioned, we don't need to call the functions in the Torch Audio backend directly. So you better use the functions Torch load with the proper backend set with the set audio backend, in case you want to set a backend. So SoxIO backend requires C++ extension module, which is included in Linux binary distribution, and this backend is not available on Windows. The SoundFile backend requires SoundFile, and then you need to refer to the SoundFile documentation for the installation. But most of the times when you install PyTorch or Torch Audio using a package management system, the dependencies can be taken care automatically, so you don't need to worry, but in certain cases you have to manually install a backend. In our case, Google Colab has already everything pre-configured, so we can simply use this torch audio load. In this case, we are passing a string with a URL, and then it will load this audio file here, and then we'll return two values: waveform and sample rate.